Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0114 indicates an intermittent interruption in the intake air temperature IAT sensor 1 in Honda Civic models from 2016 to 2021. The IAT sensor measures the temperature of the air entering the engine to assist in the calculation of the air-fuel mixture, optimizing performance and emissions. It is usually located in the duct between the air filter and the engine intake manifold, or integrated within the mass airflow (MAF) sensor. This sensor plays a crucial role in the vehicle's powertrain control module, PCM performance. The PCM uses data from the IAT sensor to adjust fuel injection and ignition timing. If the signal from this sensor is interrupted or faulty, it may lead to drivability issues, increased emissions, and possible engine performance deterioration. Accurate diagnosis and repairs are essential for maintaining vehicle efficiency. The error description for DTC P0114 signifies an intermittent connection issue pertaining to the IAT sensor. This sensor is crucial because it directly impacts engine performance and efficiency. It communicates the ambient air temperature to the PCM, impacting the fuel mixture. If the sensor is malfunctioning, or if there's an interruption in its circuit, the vehicle may experience fluctuations in performance. The IAT sensor is typically located in or near the intake duct area where air enters the engine, often in close proximity to the MAF sensor. Proper function of this sensor is vital for ensuring optimal combustion efficiency, as inaccurate readings can cause improper air-fuel ratio adjustments by the PCM. Several potential causes can lead to DTC P0114. First, damaged wiring can result from wear and tear, leading to an intermittent connection. Broken or frayed wires may expose the internal circuitry to environmental factors, causing unpredictable performance. Corroded connectors are another common issue, particularly in older vehicles or those exposed to harsh conditions. This corrosion can create a poor electrical connection, leading to intermittent problems. Thirdly, a faulty IAT sensor may directly produce this code if its internal components fail or if its calibration drifts. Each of these potential causes needs careful examination to ensure proper identification and correction. When DTC P0114 is present, the driver may notice various symptoms impacting the vehicle's operation. One of the most prevalent issues is erratic engine performance, which can manifest as hesitation or stalling during acceleration. The vehicle may also experience increased fuel consumption due to an improper air-fuel mixture, as the PCM may compensate for erroneous temperature readings. Additionally, rough idling can occur where the engine doesn't run smoothly while stationary, leading to potential vibrations or uneven engine noise. Awareness of these symptoms is critical for timely diagnostic actions to avert further engine damage or deterioration. The first troubleshooting step for DTC P0114 involves confirming the error through the vehicle's diagnostic system. Begin by turning the vehicle to the on mode without starting the engine. This prepares the onboard diagnostics to communicate with a diagnostic tool, such as the HDS, Honda Diagnostic System. Next, clear the existing DTCs using the HDS, allowing the vehicle's system to reset. Following the reset, check for any pending or confirmed DTCs. If DTC P0114 is indicated after these steps, the issue has been confirmed, and you can proceed to the next diagnostic step. If not, this suggests the possibility of an intermittent fault. In such a case, it's essential to check the MAF sensor and IAT sensor 1 for poor connections or loose terminals. In troubleshooting step 2 for DTC P0114, the focus shifts to checking for a shorted wire in the TA2 line. First, switch off the vehicle and ensure it is in the lock mode. Next, jump the SCS line, which stands for the Service Check Signal Line, using the HDS for diagnostic purposes. This action ensures the system is in a proper state for testing. After waiting for more than 1 minute, disconnect the necessary connectors, specifically the MAF sensor/IAT sensor 1 5P connector and the PCM connector number 1, which has 96 pins. Once these disconnections are complete, continuity checks can begin. This is essential to determine whether a short circuit exists in the wiring that affects the sensor. The third step in the troubleshooting of DTC P0114 involves checking for continuity in the TA2 wire. With both the MAF sensor IAT sensor 1 5P connector and the PCM connector number 1 disconnected, the vehicle should still be in the off mode. At this stage, use a multimeter to test for continuity between the tested points. Specifically, you're checking from the female terminal number 5 at the MAF sensor IAT sensor to terminal number 52 at the PCM. If continuity exists, this indicates that the TA2 wire is intact and working correctly, and you would need to move on to the next diagnostic step. If continuity is absent, it indicates an open circuit in the wiring, and repairs would need to be made to rectify this issue before further troubleshooting. In the fourth troubleshooting step for DTC P0114, the focus shifts to the SG-AFM line. This line is significant as it sends airflow measurement data between the MAF sensor/IAT and the PCM. Again, ensure that both connectors are disconnected and that the vehicle is in the off mode. Using a multimeter, check for continuity between the female terminal number 2 of the MAF sensor/IAT and terminal number 35 of the PCM connector number 1. If continuity is detected, this indicates that the SG-AFM wire is functioning correctly. Consequently, replacing the faulty MAF sensor/IAT sensor 1 may be necessary to resolve the persistent issue. Conversely, if continuity is absent, it indicates an open wire situation, necessitating further repairs to ensure proper connectivity. Once repairs have been made, following the troubleshooting protocols for DTC P0114, it is essential to conduct a final repair verification process. Start by testing the engine operation to observe if it runs smoothly and performs as expected without any interruptions. Following this, use the HDS to confirm that there are no remaining DTCs in the system. It is critical to ensure that the fault associated with DTC P0114 does not return. Lastly, carefully observe for any error codes during engine operation. This verification phase is vital to ensure that the identified issue has been completely resolved, effectively restoring the vehicle's performance and preventing further complications. To prevent future occurrences of DTC P0114 and maintain vehicle performance, implementing a robust preventive maintenance routine is essential. Regular inspection of connectors associated with the MAF sensor and IAT sensor can help identify potential issues such as corrosion or loose connections early on. It is also advisable to routinely assess the wiring conditions for signs of wear, fraying, or other damage, as these can lead to intermittent issues. Additionally, keeping sensor connections clean will help ensure uninterrupted communication between sensors and the PCM. Regular maintenance can significantly extend the lifespan of these components while maintaining optimal vehicle efficiency. In conclusion, understanding the role of the IAT sensor is crucial for diagnosing DTC P0114 effectively. By following a structured series of diagnostic steps, technicians can accurately identify and address the root cause of issues relating to the IAT sensor, thus ensuring proper vehicle performance. Diagnosing and addressing wiring integrity, as well as connector quality, is fundamental to resolving intermittent errors. Moreover, engaging in preventive maintenance can drastically reduce the risk of this issue recurring, helping to sustain the vehicle's reliability and efficiency. Properly managing these components isn't just about addressing existing issues, but also preventing future complications that can arise from neglect. Please like and subscribe to the channel. See you next time.